What if a computer could spot skin cancer with 95% accuracy? Sometimes even faster than a dermatologist. It sounds futuristic, right? But it's happening right now. Artificial intelligence, or AI, is transforming how we detect cancer using something called convolutional neural networks, often shortened to CNNs. These systems can analyze images of the skin, recognize subtle details invisible to the human eye, and flag early warning signs within seconds. In this video, you'll learn how it works, how accurate it really is, and why this breakthrough could change early cancer detection forever. Let's start with why this matters. Skin cancer is the most common form of cancer in the world, affecting millions of people each year. There are three main types: melanoma, which is the most serious, but also the most curable if caught early; basal cell carcinoma, or BCC, which is slow-growing and very common; and squamous cell carcinoma, or SCC, which can spread if left untreated. The earlier these cancers are found, the better the outcome. When caught soon enough, nearly all skin cancers are curable. But the challenge is that detection depends on access to specialists and human expertise. A dermatologist examines the skin, may use a dermoscope to magnify suspicious spots, and performs a biopsy if needed. It's an effective process, but human eyes can get tired, and not everyone has easy access to expert care. That's why scientists turned to AI, to give doctors eyes that never tire. So, what exactly is a convolutional neural network? Think of it as digital eyesight that's been trained on thousands, sometimes millions of photos of skin lesions. During training, the system looks at each image and learns what makes a mole harmless or dangerous. It studies edges, colors, and textures, features that even the sharpest human eye might miss. When shown a new image, it compares what it sees to everything it has already learned and predicts whether the spot is likely benign or cancerous. It's like teaching a detective what suspicious moles look like, then letting them investigate millions of clues across all skin types and tones. This is where convolutional neural networks in healthcare truly shine, spotting complex visual patterns that humans could never analyze at such scale. So where does that 95% accuracy claim come from? Studies show that CNNs can reach between 90 and 97% accuracy on carefully controlled image datasets, matching or even exceeding many human dermatologists. In a 2017 study published in Nature, researchers at Stanford trained a CNN on more than 129,000 skin images. The algorithm's performance matched 21 board-certified dermatologists. A later 2023 meta-analysis of 63 studies found an average sensitivity of 92% and a specificity of 89%. In simple terms, that means out of 100 skin images, the AI gets about 9 out of 10 right. That's impressive, but real-world conditions aren't always perfect. Lighting, camera quality, and the diversity of skin tones all affect how well AI performs. So, 95% accuracy is best viewed as a research milestone, not a guaranteed result for every patient. Even with those limits, AI is already helping doctors in powerful ways. AI-powered screening tools can assist with faster triage, second opinions, and better access in rural or underserved areas. In 2024, the US Food and Drug Administration cleared the first handheld AI device for primary care use, called DermaSensor. It allows general practitioners to scan a mole and receive a quick, data-driven risk assessment. And here's what's exciting. When AI and dermatologists work together, accuracy actually goes up, not down. A 2024 Nature Medicine study showed that AI combined with human expertise outperformed dermatologists working alone. So this isn't about replacing doctors. It's about empowering them to make faster, more confident decisions. Of course, no technology is perfect, and AI skin cancer detection has its challenges. One major issue is dataset bias. Most training images come from lighter skin tones, which can make AI less accurate for people with darker skin. A 2022 JAMA dermatology study called this out as one of the field's biggest gaps. Image quality is another factor. Poor lighting, shadows, or blurry smartphone pictures can confuse even the smartest algorithms. Consumer apps also vary widely in accuracy. Some perform well, but others can misclassify lesions and delay treatment. And privacy matters. Any image you upload for AI analysis becomes medical data, so always check that it's protected under HIPAA or GDPR standards. The key takeaway: AI is an assistant, not a doctor. So what's next for dermatology AI as we head into 2025 and beyond? We're entering an era of explainable AI, systems that can show why they flagged a certain spot, using color heat maps or confidence scores. Hybrid models will combine image analysis with patient data, such as age, family history, and sun exposure, giving even more precise predictions. And teledermatology, remote consultations, will soon integrate AI to help prioritize cases and shorten wait times for specialists. Imagine going to your regular checkup and your doctor uses a small handheld scanner that spots a problem mole before you ever notice it. That's the future of early detection. Fast, connected, and empowering. Now let's talk about what you can do starting today. Do monthly self-checks and follow the ABCDE rule: asymmetry, border, color, diameter, and evolving. Schedule an annual visit with a dermatologist, or sooner if you notice new or changing spots. Use AI apps or tools only as helpers, not replacements for medical exams. Keep photo records of your skin to track subtle changes over time. And ask your healthcare provider if they're using or testing any AI-assisted technologies, because technology alone can't cure cancer, but paired with curiosity, awareness, and care, it might just save a life, maybe even yours. If you found this video helpful, share it with someone you care about, and subscribe for more science-backed ways to protect your health and stay informed.